All right, Matthew. So let's look at these polynomial functions. First of all, let's go through our definition here of our polynomial function. This is a part that usually you read the textbook and you're like, what the heck is this talking about? This is all it's saying. You have this function a sub n times x sub n, and what that means is a sub n minus 1, a sub 1, a sub 0, all those are just real numbers. They could be fractions, they could be square roots, they could be anything as long as they're real numbers. So no imaginary numbers, we're good, all right? Our exponents, we want them to be whole numbers, all right? We're gonna talk about this. For this polynomial function, this has degree n here. So whenever we're talking about the degree, all we're referring to is the largest exponent that you see. So make sure all these are in descending order. Start with the biggest one, work your way all the way to the smallest one. Got it? All right, so here's an example of a polynomial function, right? You have a real number, a real number, a real number as your coefficients, right? And coefficients, those are just the numbers in front of our variables. And look at your exponents, 5, 4, 2. They're all real numbers, so we're whole numbers, we're good. Let's look at an example of something that's not a polynomial function, right? Notice the square root of x, that's really x to the 1/2 power. You can't have a fraction as an exponent. This one right here, if I were to rewrite this, this would be x raised to the negative first power. You can't have a negative exponent. And look at our coefficient here. It's a complex number, so you have an imaginary number here, that's not real. Right? So again, there's so many reasons why this one is not a polynomial function. So I just wanted to show you that. All right. So when you're looking at graphs of polynomial functions, if you want to tell if a graph comes from a polynomial function, well, number one, look how it's smooth and continuous. So when I say smooth, it doesn't have like these sharp edges, just like this one does, right? It's because if you touch it, you just might cut yourself. So you want it to be smooth and continuous. And when I say continuous, just pretend you're drawing it with your Apple Pencil here, and you don't have to pick up the Apple Pencil. So for example, if I go to this example, I'm drawing it, notice I have to pick up my pencil and then start back up down here, right? So when we say continuous, just pretend you're drawing it and you don't have to pick up that pencil. There are no holes and there are no gaps. All right. So this is our basics of a polynomial function. So now what I want to look at is, let's go ahead and figure out how am I going to describe the end behavior? How do I know what the end behavior looks at? So follow me. All right, so when we discuss and talk about end behavior, what we're looking at is what happens to our graph as we go all the way to the left and all the way to the right. Well, first let's talk about how we're going to describe it, because we don't want to write all this in words, right? So what we're going to use is the following notation. We're going to say x, and we have this little arrow to and then infinity. So what this means is, as x approaches infinity. So as I'm moving to the right, what is my graph doing? Likewise, x approaches negative infinity. So as I go to the left, what is the graph doing? Is it going up or is it going down? That's the big question, right? F of x represents the height. So f of x approaches negative infinity. That's what this means right here. And so that means your height approaches negative infinity. So you would see your function going down. F of x approaches positive infinity, right? So that would be represented by the graph going off to positive infinity. All right, so what we're going to do is we're going to put this notation together to describe what these functions are doing, the ones that we're going to look at. All right, so let's go ahead and let's look at some functions. All right, so let's start with some basic functions that we already know. All right, so let's go with our x cubed function. All right, so we could see as I go to the left here, our graph is going to negative infinity. As I go to the right, our graph is increasing. So using our notation, look what we say, as x approaches infinity, so as I go to the right, y, which is our f of x, also goes to infinity. So there you have it, right? As x goes to negative infinity, so that means as I go to the left, Look what's happening to my f of x, my y. My y is going to negative infinity, right? So again, we're just getting practice with this notation. Likewise, if I put a negative in front, that graph flips. So as x goes to negative infinity, my height goes to positive infinity, right? So all that means in English is as I go to the left, my graph increases. As I go to the right, my graph decreases. My function decreases, all right? Likewise here, we have this parabola, an even function, right? So as x goes to negative infinity, as I go to the left, my function increases. And that's what that says. As I go to the right, my function increases, right? So again, it's much easier to talk about this using symbols, right? It's much faster. And then likewise, as I go to the left here, my graph decreases. That's what that's saying. And as I go to the right, my graph decreases. And that's exactly what I see. All right, so what happens when they actually give you a function? So let me teach you how to dissect that quickly. Here's the chart I want you to copy down. But before you copy that down, make sure you smash that like button, subscribe, and tell a friend about our channel, right? We're trying to grow here. So when I say n is even, what I'm talking about is the degree, right? The biggest exponent that you see, that's what you're looking at. So if n is even, you have two possibilities. Both of these sides, as I go to negative infinity and positive infinity, are increasing, or they're both decreasing. When our degree is odd, we're gonna see the opposite ends doing the opposite. One end will be decreasing, one end will be increasing. So how do I know which is which? All right, so let's go ahead, let me show you what to look for. First things first, decide is n even or odd. So here, our exponent, our largest exponent, our degree is odd. So that means I'm gonna ignore these two, I'm not looking over here. So I have one of these two situations. How do I know which one I'm looking at? That's when you go ahead and look at your leading coefficient. Notice how it's negative. So because our a is negative, right, it's less than 0, what that's telling us is that our graph as x, right, so as x goes to negative infinity, look what your graph is doing. It's going off, your height is going to positive infinity. F of x is going to positive infinity. And as x goes to positive infinity, which just means as I go to the right, look what your graph is going to do. Your graph is going to fall to negative infinity. So f of x goes to negative infinity. All right. So again, just these two little pieces tell you so much about the end behavior, what's happening in the end. And right now, we're not interested in what's happening in the middle here. All we're talking about is what's happening in terms of as x goes to negative infinity and as x goes to positive infinity. That's all we're looking at. All right, let's do one more problem that's a little bit more complicated. All right, so here in this problem, we see that our function is in factored form. It's been factored for us, and that's going to be very helpful later on once we jump into multiplicity and other ideas. But right now, it might make this a little bit more confusing, but no need to worry, right? Dr. Math has your back. So this is what you're going to do. Notice if I'm interested, if I really want to know about the degree, right? What you're going to be doing is, some people might make the mistake, I've seen it all the time, and they would actually write 2x minus 3 times, right? They would make 3 copies and then distribute everything. That takes forever. Then they would do the x plus 4 2 times and then multiply everything together, and by the time they finish, the school year was over, right? So we don't want to do that. What you're going to do is, because we're focusing on those leading terms, what you're going to do is you're going to take the leading term of this factor and the leading term of this factor, and of course this one's already, that's the only thing there. So we're going to take all 3 of those and we're going to multiply them. And what that's going to provide us with, right, that's going to provide us with the leading term, and that's what we're interested in, right? Because from there, once you have the leading term, then you know the degree, and then of course we're going to know the sign. So let's look at this. So let's simplify this. So we end up with 1/4 x, 2 to the 3rd power is 8, and of course x to the 3rd power is x cubed, and then we have another x squared. All right, so let's count all our x's. We have Notice this one's to the first power. We have 3 right here and we have 2 right here. So we have a total of 6 x's, right? Some of you watching at home, you have way more x's than that. And then we have the 1/4 times the 8. So let's go ahead and simplify that. 8 divided by 4 leaves us with 2. So we're left with 2x to the 6th power. Alrighty, so let's see, what are we interested in? Well, number 1, our exponent. It's even. So right away, we're ignoring these 2 possibilities, right? So are both sides increasing or are they decreasing? Well, notice our leading coefficient here is positive, right? It's bigger than 0. And because it's positive, we know we have this situation here. So as x is going towards negative infinity, what we're going to see is that f of x is going towards positive infinity. And if we look at the other side, as x is going towards positive infinity, right, what we're going to see is that f of x is headed off there to positive infinity as well. All right, and so there you have it. Now you know the end behavior. And in our next video, we're going to see how to work with these factors and gather the x-intercepts and multiplicities. All right, so make sure you subscribe so you don't miss out. All right, mathletes, so hopefully this video was helpful. Don't forget to smash that like button, subscribe, and we'll see you guys in the next video. Peace.